So sketch some, and a contour plot is various level curves. Okay. So if you want to sketch a contour plot of a certain function like this, then you need to sketch maybe 3, 4 level curves. And what are the level curves? You basically consider the function and make it into a constant c, like this, and then you choose different values of c. Yeah. So the function is minus x squared plus y. Make it equal to a constant c, and then we take different values of c. For example, when c is equal to 0, we get minus x squared plus y equal to 0. So we get y equal x squared, which is a parabola. Yeah, you can see it here. And you graph the parabola. So that is one level curve. You want another level curve? That means you need to choose another value of c. For example, c equal to 1. Yeah. So in this case, the equation will be y equal. Can you see? If I take the constant c equal to 1, you're not following, yeah? Y will be 1 plus x squared plus 1, yeah? Which is still a parabola. It's like x squared, but pushed up by 1 unit. So it becomes up. It's not drawn, but same thing. You could take c equal, I don't know, 4. Then you will get the equation. In this case, will be y equal x squared plus 4. These are all parabolas, yeah? They're all parabolas. So c is 4, 2, minus 2, 4. So how many level curves do you see here? 5, yeah? 1, 2, 3, 4, 5. These are all level curves for this function here. It's like, remember when we took z equal 4, for example, before, when we wanted to graph in 3 dimensions, we were choosing some values of z. The same thing here. Imagine this being z, then this z, I give it different values, 0, 1, 2, 3, etc. So we get that. How about the g? If you want level curves for g, so you will have the equation x squared plus y squared equal to c. What are the level curves in this case? Circles. Yes, they will be circles. You can see that in this case, yeah, for the function g, which is x squared plus y squared, then you say x squared. To find the level curves, I need to consider this and then choose different values of c. When c is 0, by the way, I get just the point 0, 0, and then when c is 1, which is a circle. No, a circle, yeah? X squared plus y squared equal to 1. It's a circle centered at 0, 0 with the radius of 1. So you can see it here. The curve c equal to 1. You could take c equal 4. Whatever value you want to choose will give you a level curve. So this is also a circle, but the radius, of course, now is 2. Yeah. So you will get radius 2 here. So 1, 2, and so on. So you can find as many. Here, can you take c negative? No. why the value of C cannot be a negative number? Because x squared plus y squared, can it be negative? No. Two squares together will not give you a negative. Whereas before, it's okay to take C equal negative number. That's perfectly fine. So you will get different. Here, the values of C are just maybe greater than or equal to 0 only. So these are the level curves for that. Yeah. Now, in 2 dimensions, we have level curves. For 3 dimensions, we have level surfaces. So it's the same idea. So I want to level surfaces. So what do I do? X squared plus y squared plus z squared equal to C, yeah, to C. And then you choose different values of C. And you can see that for each value of C, what is the surface? It's a sphere. Yes, it's a sphere centered at the origin with a radius of square root of C, whatever. So when C is 1, it's going to be a sphere of radius 1. So when C is 1, your surface is here. Yeah. This one, yeah, 2. Yes, C is 2. When C is 2, by the way, what is the radius of this sphere? Square root of 2, yes. Square root of 2. Yeah? It's always the radius. If you want, I can write here. Basically, this equation describes a sphere centered at 0, 0, at 0, 0, 0, and the radius is square root of C. So these are the level surfaces. And that is basically this section. Now, let's perhaps do some of these questions. So, describe and sketch the domain of this function. So, for this function, what should we have? Yeah. So, what are we going to do here? X plus y should not be equal to 0. Huh? So, I will put y equals 0. So, that means y equal to minus x, yeah? So the domain is everything in the plane except the points which are on this line. So if I want to sketch it, so let me just put here, D is all the points in R2 except the points x, y, such that y is equal to minus x. This is except. Huh? So if you draw the line y equal minus x, which is this line, so the domain will be all of this and also all of this, so except this red line here. So you take a point anywhere in this green shaded region, you can find f. You take a point on the red line, will you be able to find f? No. For example, if I take this point, what do you think this point is? 1 minus 1, so yeah. X. Now, if you try to find f of 1 minus 1, 1 over 0. It will give you 1 over 0. So it doesn't exist. Yeah? So that means the points on this red line, basically, you cannot find f there. Here, I think you should be able to tell me what the domain of this function is. Can you? Yes. So the whole of R2 except the parabola y equal x squared. So exactly the same. You can graph it if you want. It's not really a big problem to graph it. So every point in R2 except. Now this one, yes, x squared plus y squared minus 1 should be greater than 0, which means x squared plus y squared is greater than 1, which is where okay. Where is the region x squared plus y squared greater than 1? Where is this region? If you were to graph it, where will it be? I think we talked about this. Is it inside the circle?
Outside.
It's outside the circle. So, or no? Yes. So basically, remember, in a circle, on the circle it's equal, inside the circle it's less than, outside. So basically, if you graph your circle of radius 1, then the domain is outside of this circle. Without the minus? What do you mean? What? Can you give me one point? Do you think it will not work? Which point will not? What do you mean minus? I don't quite understand. What we're saying here is that if you take a point inside the circle, can you find the f? Will you be able to find f? No. For example, f of 0, 0. Try f of 0, 0. It will not work because 0, 0, minus 1. It's minus 1. Then minus 1. Can you find line minus 1? No. So anything inside this circle is not in the domain. But any point outside, for example, let me take this point. What do you think this point is? This one. 0 minus 2, sir?
Yes.
Do you think you can find f of this point?
Yes.
Yes. Check it. Because x squared is 0, okay. But what is y squared? 4 minus 1, 3, then of 3. Can I find it? Yes, that's okay. Do you understand? So anything outside the circle is perfectly fine. Inside, no. Now, this one, a little bit, this one has two circles. Basically for this, 4 minus x squared minus y squared must be greater than or equal to 0. Yes? This means x squared plus y squared less than or equal to 4. That means our points are inside the circle of radius. What is the radius of the circle? 2. Inside the circle of radius 2. First condition. Second condition, x squared plus y squared minus 1 must be greater than 0. Here, not equal, yeah? Can you see why I didn't put equal? Because it's in the denominator. So that means x squared plus y squared greater than 1. That means what? Outside the circle of radius, 1. So therefore, inside the circle of radius 2, but outside the circle of radius 1. So it means it's between the two circles. So I will do something like this. It's basically between these two. This is the domain of our function. D is this region, like a donut, between these two circles. But be careful, it does include the circle of radius 2. So points on the circle of radius 2 are okay. But points on the circle of radius 1 are not okay because it's greater than 1. So they are not included in the domain. Do you understand this? Circle of radius 2 is included because less than or equal. So points like, for example, the point 2, 0 is fine. You can see, you can check that if you want f of 2, 0, it will be perfectly okay. But point like 1, 0, will you be able to find f of 1, 0? No. Why not? Yeah, because if you substitute, the denominator will be 0. If you take the point 1, 0, and you want to find f of 1, 0, it's not going to be available. So therefore, the domain is between these two circles. Include the first circle of radius 2, but not including circle of radius 1. Okay, I think we did enough work today. Any questions? Anything? You're okay? Is it clear what we are doing? Am I fast? Am I slow? It's okay? Things are all right? Okay then, girls. Thank you. Have a nice day. Enjoy the weekend. Yes, Salah, less than 1 is not in the domain. Yeah? So the domain is only between the two circles. Yeah. So the domain, I can write it. Yeah. As all the points x, y in the plane R2 such that x squared plus y squared is greater than 1, but less than or equal to 4, like this. So you can write the domain like this, which means it's just between the two circles. Sorry? Yes. She's not online. No problem, don't worry. This week, everyone is present. It's fine. Don't worry. Okay, thank you. Have a nice day.